the next one, we are busy with writing formulas. So we're busy with compounds, and we are busy with compounds where non-metal atoms join. What are those compounds called? Covalent. Covalent. So we're busy with covalent bonds. And what do I know about a covalent bond? Yes, between nonmetals, and what happens? What happens? Electrons are shared. Electrons are shared between non-metal atoms. So this is number 3. Hydrogen and oxygen joins. So where do we start? We start with the symbols. Hydrogen. In which group is it? It's in group 1. So how many valence electrons does it have? 1 valence electron. And how many bonds can it form? If it's got 1 electron to share, how many bonds can it form? No, it can form 1 bond. It can form 1 bond. If it's got 1 electron to share, it can form 1 bond. Oxygen, on the other hand, is in group what? 16. How many valence electrons does it have? 6 valence electrons. Now, we're going to draw the Lewis structure to help you to see what it looks like. So, my hint to you is to put 1 electron on each side of the oxygen and just carry on until you have placed all 6 electrons. Because if you do it that way, you can see how many bonds the oxygen can form. Because the bond is there where you only have 1 electron. So there you can have a sharing of electrons, and here you can have a sharing of electrons. Like the hydrogen can have a sharing of electrons there. It comes from the idea that if you have 2 electrons in an orbital, they can't share. But if you have 1 electron in an orbital, they can be sharing to fill that orbital. So how many sharings can take place here? So how many bonds can form? 2 bonds. How many hydrogens would I need to make 2 bonds with oxygen? So I need 2 hydrogens. 2 times hydrogen. Okay? To use the Lewis structure, we put the oxygen down, we repeat its electrons, and here where oxygen had 1 electron, it shares with hydrogen. Here where oxygen had 1 electron, it shares with hydrogen. So 2 hydrogens and 1 oxygen will make water. Water. So the ratio between the water, the elements in the water is 2 hydrogens to 1 oxygen. So this is dihydrogen oxide in the science world, and in the whole world this is called water. But now you can see why the formula for water is H2O. It's because oxygen can form 2 bonds and hydrogen can only form 1 bond. So you need two hydrogens to join up to the oxygen. You see, you are confident with H2O because they taught you this right from in the primary school somewhere. But now we need to be able to do more, and we don't want to learn all of them off by heart because there are too many of them. So we need an understanding of why the formulas of compounds are the way they are. So here we go. Hydrogen is an element in group 1. So it's got 1 valence electron. I place it as a little cross there with the H. Sulfur is in group 16. How many valence electrons does it have? 6. If I start there and I put one little piece on each side of the sulfur and I carry on, I will get it sorted out. I'll see that there are 2 electrons together, 2 pairs of them, 1 electron alone, 1 electron alone. So where can the bonds? It's got 6 valence electrons. How many bonds can hydrogen form? A bond must share electrons. So here there's a missing electron, so it can form 1 bond. How many bonds can a sulfur form? There, a bond can form there, and a bond can form here. So the sulfur can form 2 bonds. How many hydrogens do I need to join up to the sulfur? 2. So we need 2 hydrogens. So I times the hydrogen by 2 there. To try and explain to myself why sulfur with its 6 valence electrons will share electrons with hydrogen there and share electrons with hydrogen there. So what's the formula for hydrogen joined to sulfur? It is H2S. What's the ratio between the atoms? 2 hydrogens to 1 sulfur. What's the name of the compound? Hydrogen? No. Listen carefully. Sulfate is something else. This is the element sulfur that changes into a compound hydrogen sulfide. The element's name changes to a DE. Hydrogen sulfide. Okay. There is a quicker way to see this without these kisses. But first I want you to understand why it is like that. So number 5. Because hydrogen is in group 1, it's got 1 valence electron, which I represent with a kiss to make it more visual. Nitrogen, in which group is that one? Nitrogen is in group 15, which tells us how many valence electrons it's got. 5 valence electrons. So, I'm going to place them. 5 things. Troy, please. 1, 2, 3, 4, 5. By doing that, you see that there is 3 places where the electron is alone. So it can share an electron there. That is a bond. And here, there's another one. It can share an electron there. So that's another bond. And here, we have another place where an electron can be shared. So this thing can take 3 bonds. This is the thought process that you go through. And hydrogen can share 1 electron there, so it makes 1 bond. So, hydrogen can form 1 bond, nitrogen can form 3 bonds. How many hydrogens do I need to make 3 bonds? So that is why I say 3 times hydrogen. And the nitrogen will make, now I put them close together so that they can show the sharing. So nitrogen originally looks like this, and hydrogen comes and shares there, another hydrogen comes and shares there, and another hydrogen comes and shares there. What's the formula of the compound? Now I know that we are used to putting the H first. For some other reason, they put the H last here. So I said that it's trihydrogen nitride, which is right. But you could also say this is nitrogen trihydride. And that is the preferred way. But no, my dearie, nobody talks about the nitrogen trihydride that you have in your house. You talk about ammonia. Oh. Handy Andy scrubs ammonia. You use it to clean surfaces. Farmers use it as a fertilizer. It's one of the biggest industrial plants in our country, making ammonia. What is the ratio between the elements? 1 nitrogen to 3 hydrogens. So hydrogen, I know by now, hydrogen is in group 1. It's got 1 valence electron and it can form 1 bond. I know phosphorus is in group 15. It's got 5 valence electrons. And I start off by putting 1 electron on each side, and the 5th one will go there. Then I can see that with the 5 valence electrons, there are 3 places where a bond can form. So there are 3 bonds that the phosphorus can take. So this has got 1 valence electron. That's why it can form 1 bond, and this one has 5 valence electrons. So I need how many hydrogens to form a bond? 3 times hydrogen. So we go for phosphorus with its 5 valence electrons. There a bond can form, there a bond can form, and there a bond can form. So the sharing of electrons is what forms the chemical bond, and we have pH3 or H3P. I will not penalize you. If you write pH3, the ratio is 1 to 3. If you write H3P, the ratio is 3 to 1. If you write pH3, it's phosphorus, trihydride. If you write H3P, it's trihydrogen phosphide. You see, the name of the element that you write last changes, like hydrogen changes to hydride, and if you write it this way, phosphorus changes to phosphide. You'll find that rule in your textbook somewhere. Yes.
The number of times that you count
hydrogen,
it is because of the bonds.
Yes, I need 3 bonds to be formed there.
So then
And hydrogen can only form 1 bond. So there I need a hydrogen, there I need a hydrogen, and there I need a hydrogen. That's why I times because you've got 3 hydrogens, you multiply by 3.
Thank you.
Right? So the hydrogen story we know by now. We know it's got one kiss, and we know it can form 1 bond. We know that. Carbon is the first time we're doing carbon. It's got 4 valence electrons. And if you put 1 valence electron on each of the 4 sides of carbon, you will be able to see that it can form 4 bonds. Okay? So they form the 4 bonds there, and here, and here, and here. So how many hydrogens must I join? I will need 4 hydrogens. Yes. So this makes 4CH4. And we are busy with molecules or compounds that are formed by a sharing of electrons between non-metal atoms. So these represent covalent bonds. Aye. Listen carefully. Listen carefully. It's carbon, tetrahydride. Because there is 1 carbon and 4 hydrogens, the ratio is 1 to 4, and it is carbon tetrahydride. Listen carefully. It's called methane.
Some people really thought that it is.
And this is your first ever lesson in organic chemistry. Methane. Right. Okay, so let me walk you through it. I'm sorry, but I need to give everybody a chance to understand. So we're sick and tired of this hydrogen with its 1 electron and its 1 bond by now. Now boron is in group 13. It's got 3 valence electrons. Put the electrons 1 on each of 3 sides. Then you can see how many bonds it can form. So this one can form 1 bond, and this one can form 3 bonds. Okay? So how many hydrogens do I need? I need 3 hydrogens to join to the boron, and then it will make B, where a hydrogen shares electrons with a boron there, and a hydrogen shares electrons with a boron there, and a hydrogen shares electrons with a boron there. So this is BH3 with 1 boron to 3 hydrogens being the ratio. And this is boron trihydride. So first of all, we're on number 9 now, and it's carbon and oxygen. But first I want to explain something, so if you would just put your pens down and listen first. Up to now we have had only the sharing of 2 electrons at a time between atoms. Now look, oxygen has a special property. Oxygen is in group. How many valence electrons? 6. So I'm going to put the 6 electrons down. and I'm going to show myself that there you can have a sharing and there you can have a sharing. But now oxygen, we used to teach you that oxygen is diatomic. It means that one oxygen atom joined up, formed a bond with another oxygen atom. So if you have two oxygen atoms, how many bonds can two oxygen atoms form? There is a bond there, possibly, and there's a bond there, possibly. So, there are 4 electrons shared between two oxygen atoms. Listen, 4 electrons shared between two atoms. Let me draw them so that you can see how the words are changing into symbols. 4 electrons are shared between two atoms. There they go. And yes, 4 electrons are shared between. If you're lying between your mother and your father, you're in between them, you're in the middle. So the 4 electrons is in the middle of the two oxygen atoms. Basically. So how many bonds are there? How many bonds are there? How many bonds are there between hydrogen and boron if 2 electrons are shared? How many bonds? 1 bond. So 2 electrons shared means 1 bond. Sharing 2 electrons means 1 bond. So if I go to 4 electrons shared, we call this 2 bonds. So it's called a double bond. Okay, now I'm going to do the next one with you to help you to see that there are double bonds formed between carbon and oxygen. So first of all, carbon has 4 valence electrons and it can form 4 bonds. How do I know that? It's in group 40, so I can put 4 crosses around the sides of the carbon. Oxygen, we know, oxygen has 6 valence electrons and it can form 2 bonds. 6 valence electrons. I know that quickly because it's in group 16. If I look at the periodic table, it can form 2 bonds. How many oxygens do I need to join the carbon? Yes, because 1 oxygen forms 2 bonds and I need to make 4 bonds. How many oxygens do I need? 2. I need 2 oxygens. So I'm going to show that by multiplying the oxygen by 2. And then I'm going to draw a carbon in the middle. And now I know carbon can form 4 bonds, but oxygen must form 2 bonds. So I will have to put 4 electrons between the oxygen and the carbon. And the same on the other side. I have to put 4 electrons between the carbon and the oxygen. This is a challenging one. But if you're confident with the first lot, you can move on to the next step now. So carbon joins to 2 oxygens. What is this carbon's name? Carbon compound's name? Yes, CO2 is carbon. Yes. Please don't be upset with me. Carbon dioxide is like water, a common compound where you learnt the formula in primary school already. So you know them. Now I showed you why it is CO2. Because you see, you can't learn the formulas of all the compounds off by heart. It's too much. So now I'm teaching you the skill Carbon can form 4 bonds, oxygen can form 2 bonds, so I need 2 oxygens to join to the carbon. Right. How many valence electrons? 4, so for my sake I'm going to put 1 on each side, then I can see that it can form 4 bonds. And oxygen, how many valence electrons? 6, because it's in group 16. 1, 2, 3, 4, 5, 6. And it can form 2 bonds. And I don't even have to draw these things with all the crosses, because I can see by looking at this, 4 bonds for oxygen and 2 bonds for 4 bonds for silicon and 2 bonds for oxygen. I know I must multiply 2 by 2 to get 4. So I must multiply the 2 by the oxygen by a 2. So I can see, without drawing anything out, silicon forms a bond with 2 oxygens. I don't have to go with all these crosses, because I can see the pattern I can now see the pattern, so I don't have to say Si with 4 electrons shared between oxygen and another 4 electrons shared between the silicon and another oxygen. I don't even have to do this anymore. On the first page there is some writing. I don't want you to do these ones on the first page now. I want you to do these. Try and do them without copying from the notes that you've got. If you have to, after you've tried, check yourself.